First of all, thank you very much for your time and thank you very much for this interview.
Thank you.
So,
My pleasure.
it is very interesting job you have. I must admit that. So, what are the most recent exoplanet discoveries and how do they contribute to our understanding of potentially habitable worlds? I mean, it's a heavy question.
Yeah, for sure. I would say for me it would be the TRAPPIST system. So basically, TRAPPIST just means transiting planets and planetesimals for a small telescope. And essentially, why it's intriguing is because they actually found out that 3 of the planets out of the whole 7 planets in the system are within the habitable zone. So what that means is that the temperatures are conducive for liquid water to exist. So personally, I'm more on the hypothetical side of astrophysics, theoretical, and I don't just like shutting down an idea fast, because I would describe myself as an open-minded scientist. So I'm waiting for the day, I'm really looking forward to the day when we actually set foot on this planet and just see for ourselves whether or not life actually exists. And I think ever since I've been on this journey for exoplanets, I would say what I look forward to the most is potentially discovering life. Because I think as an astrophysicist, and in the back of my mind, I know that that's the most profound thing I would say in astrophysics is discovering whether or not other life forms actually exist. So I think in discovering exoplanets, we are also, I guess, we are moving closer to, discovering whether or not life forms actually exist. And also, you have to be open to the fact that life forms might not operate and exist like the life forms do on Earth. They might take on different structures, different molecules. So I guess, it's a very interesting field, actually. It's very interesting.
So when you take all these facts in one place, we need to be even more open-minded if we find some life on other planets.
Yes, absolutely. Because they might conform to totally different biomolecule structures than the life forms here on Earth, which are carbon-based. The ones in other planets might not be carbon-based. So you just have to keep an open mind, honestly. Yeah.
And concerning the state of quantum computing in Africa and its resultant future within the continent, what the progression has Africa made in that field?
For me, I actually did my research, and as at now, I only know of South Africa that is actually taking an initiative to embrace quantum computing. Unfortunately, it's not a very widespread concept yet. I know there are many people who are interested. I'm not disputing that, but I feel like we still have a long way to go if we want to move from classical computational methods to quantum computing, because there are not a lot of courses I know that are offered in quantum computation. You have to source international courses. You won't really find regional and local institutions offering courses in quantum computation.
And where is the world now in that kind of field? I mean, about the communication on quantum level, and is that possible to make like data transmission between Earth and spacecraft? And what is going on in that field?
It's still a very, very new concept. So as at now, everything is just still so theoretical, because there's no, for instance, NASA, I know they're looking into potentially shifting to quantum computational techniques, but there's still so much research that we have to do. because that's actually my fourth year project. I'm trying to find ways we can expedite this, because I feel like quantum computing is going to be revolutionary, not just in science, but in all other fields, finances. I mean, the financial sector, the healthcare sector, it's going to be revolutionary. And for now, there's no company or these big technological institutions that has fully embraced quantum computation. We are still researching, it's a trial and error, and it's actually a very difficult field. And I think I would say it would take years. It will take a couple of years actually for us to fully start using and programming with quantum computers. It will take years for us to make that big shift from classical to quantum.
And what are the latest findings from the James Webb Space Telescope, and how are they changing our knowledge of the universe? I mean, we don't have so often those kind of information.
Yeah. The one I think that the most was the fact that JWST was able to it made measurements that showed that that showed that the universe is actually expanding much faster than scientists actually thought. And now this was, of course, very intriguing to astrophysicists who are interested in dark energy and dark matter, because you want to find out why is the universe expanding faster than what we previously thought. And then also it was able to discover a galaxy which is very similar to our galaxy, the Milky Way. And by studying these galaxies, we are able to rewind the clock from the Big Bang Theory, and just study what happened, this and this, how this and this was formed, and essentially the fate of the universe. Yeah. And it has been taking very beautiful pictures. Yeah.
And what will be the major focus in your science in the next 2025?
My main focus will be hopefully to come up with a model, a quantum computing model that can take in astrophysical data and give me output exponentially fast. Because if I show you an example of what I do in school, sometimes I deal with very big numbers, and I just want to come up with a small quantum computational model that can process this data exponentially faster and prove that it's actually something we can do in the next few years. Because I feel like quantum computing is going to revolutionize everything. So I want to make that happen sooner than later. Yeah. And I'm very eager to do that.
What is stopping you right now?
Honestly, I have been researching from the time I joined university, and the thing is, it's such a vast field, and it's trial and error. It's honestly just trial and error. Studying. I read so many books, and because it's also still a young field, multidisciplinary field, that has been a challenge. Also getting material.